Now, before we dive into today's tutorial, let me share something fun. From the previous author's test, he was running on an RTX 4060 with 8 gigabytes of VRAM and generating just 4 seconds of audio with Hunyuan Foley. Took him about 23 minutes. Yeah, that's right. Nearly half an hour for only a few seconds of output. But on my RTX 5090, guess what? It only takes about 15 seconds, which is roughly 0.25 minutes. That's a crazy difference, right? But before we get started, I need to drop a quick disclaimer. This content is AI generated and might contain errors or things that make you uncomfortable. Please use it at your own risk and always double check with reliable sources. I'm not responsible for any consequences. The script you're hearing now was written by me, but voiced by AI. The workflow itself uses AI, but the idea behind it is still human-made. So if you're allergic to AI, maybe click away before you get infected. Also, be warned, there's always a risk you'll blow up your VRAM when trying stuff like this. I can't guarantee success, but someone did manage to get it working, and that's why I'm sharing it. And hey, scold softly. I accept my imperfections. No need to spread hatred here, we can discuss peacefully. All right, before we go deeper, I'll play the official Hunyuan Foley video for about a minute to give you some context. You can skip this part if you want. Just want to say a huge thank you for hitting 400 subscribers. I really appreciate all your support. It honestly means a lot to me. Recently, I've been playing around with Nano Banana. Honestly, I think it's better than Flux. But since it's not free, I haven't posted any updates about it on my channel. Some of you have asked whether I could make multi-talk or infinite talk work, but honestly, I think those require a lot more VRAM. I can't test them on low-end GPUs since I'm running a high-end card. But this time I saw someone successfully run Hunyuan Foley on an RTX 4060 with just 8 gigabytes of VRAM. And today I'll show you exactly how they did it and what inputs they used. So let's start with the installation. First, you'll need to git clone the repository. Head over to GitHub, the link is in the description. Look for ComfyUI Hunyuan Foley by AISTUDY Now, click the green code button, and copy the link. Then go to your ComfyUI folder, open the Custom Nodes folder, and at the top of the window, type samad to open a command prompt there. Type git clone and paste the link you copied. Wait a bit, and once it finishes, you'll see the ComfyUI Hunyuan Foley folder appear under Custom Nodes. Next, click into that new folder, type samad at the top again, and run the command to pip install the requirements. This will take a few minutes because it needs to install the transformers library. Now for the last step. If you're using the ComfyUI portable version, you'll need to run Python embedded. Here's something important. I don't recommend copy-pasting commands directly from some random website. Instead, actually find the file path yourself. So starting from your ComfyUI portable folder, go into ComfyUI, Custom Nodes, ComfyUI Hunyuan Foley, then right-click on the requirements.txt file and copy its path. Now go back to where your Python embedded folder is located, type cmat at the top, and run this command. Python embedded python.exe-m pip install-r. Paste your copied path here. By doing it this way, you'll reduce the number of errors significantly. And more importantly, you'll actually know what's going on instead of just blindly pasting commands. If you just paste and something breaks, you won't know how to fix it. Trust me, I made that mistake before and got errors. So this is just from my experience as a reminder for beginners. Next, you'll need to download the models. Create a folder called Hunyuan Foley and download the 4 required models from Hugging Face. Put them in this directory, ComfyUI/models/Hunyuan Foley/. The files you need are hunyuanvideofoley.pta, it's about 10.3 gigabytes, syncformerstate.dict.pta, it's about 0.95 gigabytes, va128d48k.pta, 49 gigabytes, and maybe a few smaller files depending on future updates. If you skip this step and just drag my workflow into ComfyUI, it's not going to work. ComfyUI will just throw errors. Once you're inside ComfyUI, make sure you select everything correctly. Choose the model file hunyuanvideofoley.pta. Set precision to FP16 and choose FP8 quantization to save VRAM. Then load your VAE as 128d48k.pta and your syncformer as syncformerstate.dict.pta. Once these are loaded, you're good to go. There's also an optional step, torch compile. This requires Triton, and I already explained how to install it in my previous 1.2.1 video. Torch compile can give you about a 30 to 40% speed up after the first run. If you don't want that, you can ignore this step. Now let's talk about sampler settings. Super important for low VRAM users. Since I don't have an 8 GB card to test on, I adjusted the inputs based on the setup that worked for someone else. So here's what I recommend. Reduce FPS from 24 down to 16. Cut the duration to just 4 seconds. For steps, try somewhere between 35 and 50. Don't go too high or you'll overload your VRAM. And here's why. The longer the duration, the more VRAM it needs. That's exactly why multi-talk and infinite talk aren't low VRAM friendly. You'll either crash or end up waiting forever. For the sampler, I usually choose Euler. Nothing too special about it. As for the seed, don't worry, I'll teach you how to use it later. Make sure you set force offload to true. That way, you'll save memory. And for combining the video, the format I use is MP4. Even though the output itself is just audio, saving it as MP4 makes it much easier for me to edit the video later on. With these settings, on an RTX 4060 with 8 GB of VRAM, it takes around 23 to 24 minutes to generate 4 seconds of audio. On my RTX 5090, it only takes about 15 seconds. So it's really about balancing quality with your hardware limits. Now, don't be surprised if you run into some bugs. I did too, and so did the person who ran it successfully on the 4060. You're not alone. It's part of the process. And that's basically it. That's how you set up Hunyuan Foley on a low VRAM GPU like the RTX 4060. By the time I generate the audio, I take my time to monitor the VRAM usage and RAM. While it's processing, it only takes up about 6.7 gigabytes, which is lower than 8 gigabytes. So I guess that's not a big issue. The only thing is, after the audio finishes generating, there's a small spike up to 12 gigabytes and even 16 gigabytes. I'm not sure if that's going to make your ComfyUI crash, but you'll have to try it yourself and let me know in the comment section below. After you've set up the workflow and run a few tests, you'll probably notice something. You can only generate 4 seconds of audio per batch. That's kind of a shame, right? Because what if your video is longer than 4 seconds? Does that mean you're stuck? Well, the good news is, no, you're not stuck. You can absolutely continue generating audio after those first 4 seconds. All you need to do is adjust the skip timeframe input. Here's how it works. Let's say you're running at 16 frames per second and your duration is set to 4 seconds. That means your next batch should start at 16 times 4 plus 1, which equals frame 65. From there, you generate the next 4 seconds of audio. Super straightforward, and honestly, it gives you the same result as if you generated 8 seconds all at once. The The key here is to fix your seed value so that you don't introduce variations in the same video. That way, it all stays consistent. To show you what I mean, let's compare two cases. On the left, we have 3 separate 4-second audio clips combined to make a 12-second video. On the right, we have one single 12-second audio generated in one go. Can you spot the difference? Once again, thank you so much for helping me hit 400 subscribers. Your support honestly motivates me to keep testing, experimenting, and sharing these workflows with you. If you found this video helpful, give it a like, leave a comment so I know you're watching, and don't forget to subscribe for more updates. I'll see you guys in the next one.